Alright, this is just a little note about symmetry. Last problem I did, 16.29, had charges in each corner of a square, and you wanted to know what the E field was in the fourth corner. And what we found was if these Q's are all the same, and indeed it's a square, this field and this field are equal. And the resultant of those two fields would be, this plus this is that. It's just going to be radical 2 times whatever E was. So the sum of this and this is radical 2. This one, similar equation, KQ over R squared. What's different though is our R, it's the diagonal. And we can make use of the same shortcut here, that the diagonal, the diagonal equals radical 2 times the side. So use the symmetry and your sort of shortcut math tricks to be able to do things. In this case, we don't want to break this E right here into components, because these two components together give you something that's in line with it, and it's real easy to add when they're in line. This will be in line with the sum of these two here. Alternatively, look for when things cancel. Oh, and one word of caution on this one. If E that was to the left, say, was a lot less than E downward, maybe because this charge up here was 2Q versus this one just being Q, realize that if you find the resultant of those two, they don't line up anymore with E due to the charge that's along the diagonal. So you can't do it that way. What you'd have to do is break this one, you wouldn't even bother finding this. You would leave this one as E in the X, leave this one as E in the Y, and this you would break into EX and EY. And then you would, sum that and that, sum E in the Y with the other E in the Y, and you'd get this, and then sum of the square rooted.